is working. Alright. So let's get to doing this. Okay, so here, just need that. Okay, so what first to do is, again, we did use malloc to allocate memory for a new person, which we have done that. Okay, so if there are still generations left to create, which is greater than 1 person, parent 0, create family generations. So this is recursion happening here, so it's calling create family again. So it's going back here saying, oh, generations -1, okay, and then person parent 2, create family generations -1 again. Okay, so here are 2 parents, but wait, put parent 0, parent 1, okay. Set parent pointers for the current person. Set parent pointers for current person. Set parent pointers. How could I approach setting parent pointers no idea how to approach it. So how could I approach okay. I have no idea how. Okay, to set parent pointers for the current person, you can assign the parent pointers to point to the other person's structures. For example, current underscore person points to parents index 1 is equal to parent 1. To set parent pointers for the current person, you can assign the parent pointers to point to other person structures. Current. Okay, they are initial. They are. Wait, no, are they? I'll get initialized. See, okay, parent 1. Yeah, okay, there. Hold on, here. Yep, they're fine. I think they're completely fine. That should be completely okay. Okay, I'll set parent. Okay, so what do you want to make sure? Okay, so this is what they want. So they want to do current person. See, this is the current person, basically. So we want to set parent pointers. Okay, use the parent. Points to parent. Okay. This points to parent 1, I guess. Okay, this points to parent 1. I'm so bad with pointers. I really need to learn my pointers. It's not a good look at all. Okay, so remind me of what the arrow does. What's this? Let's see what that does. So the arrow is access members of structure through a pointer, for example. So I feel like it's these members of a structure through a pointer. Okay, for example, current person parent accesses the parents member of the current person structure. This is the parents member of the current person structure. Okay. Interesting. So pointed to a person structure. Does that help clarify? Huh. Okay. In the context of structures, class instructions, C and C++ objects accessed directly, its members are accessed through the dot using the dot operator. When an object is accessed through a pointer, the arrow operator is used to access its members. Huh. Okay, to access measures when working with a pointer to an object. Interesting. Okay, so basically, I guess it's to connect it with the idea of a struct, right? The idea of a struct and pointers together. Huh, interesting. Okay, cool. Parents. We can search parents. And parents. Okay. Oh, so we're accessing this part of this struct. Okay. Say point. Okay. In terms of this, so we're gonna ask regarding this part over here. We want to know directly what that means. Access the parents array within the current person structure. Yes, okay, that makes sense. That makes perfect sense. That makes but okay, that makes perfect sense. That makes perfect sense. Yep. That's perfect. So we're creating a family right now, and we need to okay, yeah. So current person is the first element of the parents array. So parents array and the current person's parent one access second element. By assigning parent one, parent two, these elements you're setting the current parent point is for current. Oh, okay. Oh, okay. That makes sense. So we're making the next set of people. Okay, that's a little tough to understand, but that makes sense. All right. So our current person, we're going to be accessing our struct parents index 1 of parents, and then we're saying this is equal to parent 1. Right, we're storing this. This is going to be our parent 1 in this case. And it's going to be 1, and it's going to be equal to parent 2. Okay. So we've done that. Interesting. All right, cool. So now we've got our parent 1 and parent 2. Very interesting. And now our next word is to randomly assign current person's alleles based on the alleles of their parents. So the alleles of our parents are probably going to be in our, right here. It's going to be stored in here, 99%, I think so. So if we access this according to this, but how allele 1, does each parent have two? No. A person has 2 parents, right? A person has 2 parents, and our person also has 2 alleles as well. Correct? Let me assign current person's alleles. Okay, so we have to use a rand. I didn't even know you have to use rand here. We do have to use rand. That's interesting. That's very interesting. Huh. Give me a sec. I'll be right back. Oh my goodness. Alright, we're back. Okay. Let's see here. Alright, interesting. We've got create to, okay, we've done that. We set the parent parents. Now, this is the part where I'm stuck. Okay, randomly assign current parents' alleles based on the alleles of their parents. So, our new person, okay, this part makes sense. This part makes perfect sense. Parent 0 alleles rand. So, are we taking 1 from parent? Oh, okay, we're taking, so regarding our new person, for the first allele it's going to be taking it from our first parent, and it's going to be a random allele. It's going to be a random allele, and the second allele that he's going to get is going to be from the next parent, and it's going to be alleles, again, we're going to use, okay, that kind of makes sense. So, again, they need to inherit 1 allele. I don't even know how to spell it. Allele from each parent. Okay, So of course we'll be working on our, if you look here, we'll see that we're working on the new person. And this is kind of the problem here, because I completely use the whack syntax here. You're actually supposed to use new person. Because where is current person? It's not even here. What am I even referring to in this case? If I change, okay, I'm not doing that. This is the right way to do this, just to state this is new person. And this can be new person as well. I don't know what I'm doing. New person. Okay, new person, and I'm gonna have another new person. I mean, same part of it, but one is going to be from parents. Wait, no. Regarding our new person's allele. So let me see. How do you spell it? Allele 0 is going to equal parent. Pretty sure it's parent 0, and how do they do this? Okay, parent 0. Okay, that makes sense. Allele, and it's going to be we're gonna call the rand. Hold up. Allele 0. Oh my goodness, not allele 0. It's supposed to be alleles. Okay, I'm trying to understand this actually. I need to understand this. Oh, look at that. Another person just joined. That's cool. Nice to see y'all. New person. Okay. So the allele is going to be, I guess, a random. The index of the allele is going to be random. That's what's going to be. The index of the allele is going to be random. How do I do this though? So I don't know how to get the random thing. How do I do that? Okay, so it's gonna get a random number. Oh, okay, I get it. That makes sense. So we're gonna hold up. So this is gonna give us modulus. I know that it's not operator. It should give me an even number. Well, no. Modulus operator. I don't even think it's modulus. For instance, remainder. What? Returns the remainder of a division operation. For example, 7 modulus 3 would return 1. So we're gonna get some random number, and it's gonna get freaking modulus, and we're going to. So if it was like, let's say you have 8 over 2, we're gonna get the remainder of that. There is no remainder, so it's gonna be index 0. But then there's probably some limitation on the random one here. I don't know. So it says S. I think this. Oh my goodness. Okay, that's interesting. That is very interesting. Okay, so what we're gonna do. We're gonna try and do this. We're gonna do this. It should be alleles. The second allele should be from the other parent, right? And if so, that's the case. If so, that is the case, then I'm guessing. Okay, I have weird looking syntax errors here. I don't know why I'm doing that. Same type of idea. It's going to be random index. Still a little unsure of how this works, how the index part works, but yeah, it should work. I think so. Yeah. So now we're getting our alleles. So it's gonna keep repeating until there's no more generations to do, right? Yeah, that's chill. That's chill. That makes sense. So we're just gonna keep going until there's wait if the greater than one. Okay, that makes sense. This is perfectly sensible. It's gonna keep doing some recursion. Keep getting our alleles. Keep getting our yeah. It's gonna randomly assign current person alleles based on the alleles of their parents. Yep, makes sense. That makes good sense. Yeah. Randomly assign current person's alleles based off the alleles of their parents. They need to inherit one allele from each parent. Okay. Randomly assign current person's alleles based on the alleles of the parents. They need to inherit one allele from each parent. If there are no generations left to create, okay. Now we're done with that. We're done with the making our generations, or actually making our family, actually. And now what we are actually going to do, if there are no generations left to create, then set parent pointers to null, and randomly assign alleles. Okay, so if there are no generations to create, so it's kind of like a tree, is it? And no, it's not a tree. I'm being stupid. You could kind of think of it as a tree, but since we're like a family tree, because you would have, but you'd start with. It's kind of a flipped tree, is it? No, it's not. I'm thinking of some weird stuff. Okay, so now we do if there are no generations left to create. Okay, so else to do set parent pointers to null and randomly assign alleles. So we need to set the pointers to parents, so this one to null if there are no generations left to create. So it's basically, this is our base case, I'm guessing. This is our base, wait, no, that's not our base case. Do we need a base case for recursion here? I guess that can kind of be thought of as our base case, I'm guessing. I don't know. Yeah, this is exactly person parents 0. It said parent pointers to null. This was what I was thinking. Randomly assign alleles. What's the point of this part? Return new created person. This is a return new return new person. Yep. So what's the point of this? Actually, I know how to do this part, but what's the point? What's the point of having this? Oops, what the hell's going on? Having this. Purpose of the echo block is to handle the base case when there are no more. Are you telling me this is the base case and this is not? Okay, that makes sense though. Yeah, no, this is possibly the base. I've never seen. If this is the actual, so you're telling me. Yeah, no, it makes sense because that's when there's nothing left to happen. That's what I was thinking, right? Yeah, because there's now this is just gonna keep running it through, and this is when okay, there's nothing else to do. Let's just set everything to null and randomly assign the alleles, and done, boom, and return the final person. So I'm guessing this is the base case, and yeah, that makes sense. Okay. So now what we're going to do is we're going to set parent pointers to null and randomly assign alleles. So to do that, it's pretty simple. New person, parents 0 is equal to null, and then new person parents null. So we've got two nulls, and then now what we need to do is randomly assign alleles. randomly assign alleles. Randomly assign alleles. Okay, so how do we... So then we're assigning it to new persons. So new person, allele, yeah, 0 is random allele, and a person allele is 0. Where is it? Okay, it's calling random allele. Where is it? Where's the random allele function? Yeah, there's the random. So it's gonna call it. It's gonna grab it from there. Okay, cool. So then I understand values. So then new person alleles 1 is going to be equal to calling random allele. Random, what is it? Random underscore allele. Allele, yep, I think that's correct. And then, wait, I did this wrong. Should be, there's 2, right? Okay. Okay, so let's just see now if that's okay. Random allele. Yep. Okay. And then just return. I've got to return newly created person. So just return new person. And then once we return nothing, return. Okay, we're basically done that. Now complete the free family. So it's interesting. I've never done this. So free family function should accept as input a pointer to a person. To a person. Free memory for that person. So again, we're doing this recursively. We're freeing it recursively, just like how we free family. It's gonna call it. Huh, okay, that's pretty cool. So at the end we should have some null value, then we're donezo. So once we get the null value, we're donezo. It's our base case, and other than that, we're just gonna keep doing some recursion. Keep freeing it. Free p parents. So our base case is when it's null. So we start with our base case. So it's taking in okay. If I completely forgot my syntax, which kind of sucks. I don't remember. So if my p, I think so, because we're taking in p, and I don't think we should be. It should not. Yeah, no, it shouldn't. Like I remember like doing this in C++ where you have to take the memory, but I don't. There's no way that's the case. We're not looking at memory. Memory is potentially because I don't know if it's dereferencing. Yeah, I have no idea. Boo. Okay. So if p is null, then just return the program. That means we want to just return. We're chilling. That's fine. That's what it's supposed to do. It's supposed to do that at the very end once it goes through everything. Now we need to do free the parents recursively. That means to keep on calling free family over and over again, right? So okay, I got a rough idea. So when we're freeing the family, so we should definitely call free family, right? We definitely should call free family. And then what if you call it twice for all ancestors? Because we have both parents 0 and parents 1. So we have to potentially call it twice for each one. So P free sit. No, free P. How I should approach this. How should I approach this? Boom. So how would you call free family for each parent of the current person? I guess it depends on the index, right? Parent 0 and parent 1. I don't know how to free it though. That's kind of. How would you free the blank for the current person for freeing the parents? Wouldn't you just do free P? When we call it, do we okay. Well, look at that. I like how this thing guides you through it. It doesn't give you answers, just guides you through it. It's a really good AI for that. The syntax is probably cooked, and I know. I feel feeling you have to do that for this. Yeah, no, the syntax is perfect. Perfect syntax. Is this it? Can we try it out? Is this it? Don't tell me this was only a. How long was this? It was a 30-minute endeavor. 30 minutes. Huh. So we potentially could just run it and see what happens. Just make it first and see if there's any bugs or whatnot. Okay, there is. It says use of undeclared identifier parent 2. Line 52. What is going on here? Okay. Oh, wait. See, parent 0, parent 1, right? I'm 99% sure that's what it should be. Right? What? Okay, hold on. Parents. What those parents? Do parent. See what happens now. I don't know. Wait, it says. Wait, what? It says. Okay, it's parent 2. Where's parent 2? Okay, that's not from there. So parent 0. Parent 0. Alleles. Parent 0. It should always be parent. Wait. Only when we're setting it to no. Pointer to no, but wait, no, new parent, parents. OG pointer between parents, parent 0, parent 1, parent 0. Yep. But what about these? Parent 0, parent 1. Why am I looking at the index? This is idiotic of me. This is exactly why. That was. No, I don't know what. Oh my goodness. That doesn't make any sense at all, but this makes sense now. Yep. I think there's probably some more errors, but let's see. Okay, it says int ran declared here ran. Oh my gosh. Okay, that makes sense. That was a good one. That was good. Keep going. Keep coming. Okay. Parents. create family. Yeah, let's try this one more time. Okay, it runs. And do we have to put what is the argument that we have to put in here? Let's see. So he's doing maybe okay, cool. ./inheritance. So oh yeah, it does everything randomly. Okay, there we go. And you do ./inheritance. It just does everything random. Let's do period. Oh, type BB. No, I'll just check 50. Check 50. So check 50 here. This one was interesting, I'm telling you. This problem was possibly the most easy so far. If I'm right, I'm probably gonna have like like a bunch of frowned faces. Okay, there's style 50. Make sure our style is correct. Probably a bunch of style effects. Okay. So they want 2 comments. Okay. Okay. What else do they want? You have problems with me with this thing. Got you. Here, what do they want? They want the P alleles to come to the bottom. What is wrong with these people? What the heck? This is not what they want. Oh no, they wanted the P alleles 1. This is kind of the most stupid thing ever. What? I don't even think this matters. Just what's wrong here now? What's wrong here? What is the difference between this and this? What is the actual difference? Oh, I'm trying to actually see. What is the difference right now between this and this? There isn't a difference. Okay, come here, boy. Let's just completely put you here. It somehow just fixed it. Here, what's the difference? Again, the P alleles thing. They want that. Oh, sorry, the arrow. Let's bring it right here. Okay. Tabbed it. I tab it right there. Tab it once more because you want one more tab, right? Okay. Maybe it's just a spacing problem. Maybe I don't have my patience right here. Do that. Okay. Boom. Look at that. Good job fixing the format. I love when that pops up. Now we gotta submit it. I submit it. Submit 50. Submit that. Huh. Okay. Let's just. Yeah. No. This was purely my own work. This is purely my own work. Totally. This thing literally carried me, man. This thing did most of my work for me. They did most of the thinking for me here. I didn't have to do any thinking. Honestly, it was pretty crazy, anyways. You know, pretty crazy. Oh, okay. Alright, so that's it for today's stream. And that's all.